Welcome to Brain Vision.
Chapter 3, problem 34 says, describe the relationship between 1, a radius of a cation and the atom from which it's formed, and 2, the radius of an anion and the atom from which it's formed. So if we think about a cation are metals generally located on the left side of the table. So let's choose one. Let's look at beryllium. Beryllium has the potential to be a cation, but as a neutral atom, it has 4 protons in the nucleus, and then it must have also 4 electrons. The first energy level, it will have 2 because that's the maximum the first energy level can have. In the second energy level, it's going to have 2 more, giving it a total of 4 for a neutral element. Then if we think about beryllium as a cation, it becomes B plus 2. And the reason why it's B plus 2 is because this energy level for an ion is either going to be full or empty. And so it's easier for this energy level to to lose 2 electrons and become a cation than would be to gain 6 electrons. So this energy level is going to lose 2 electrons and become B plus 2. The protons are still the same. And then we draw first energy level, and there are 2 electrons in it. Let's do these in red. There we go. So our beryllium plus 2 has 2 electrons on the outside, 4 protons on the inside. Beryllium neutral has 4 protons on the inside, 2 electrons in the inner energy level, and 2 electrons in the outer energy level. So if we want to consider the size, the atomic radius of this atom, for a neutral atom, the outer electrons are shielded by the core electrons of the inner electrons. And so there is an extent of repulsion between these electrons, and it therefore cannot feel this positive nuclear charge. However, these inner electrons here are not shielded. There's nothing further inside. These are the inner electrons, and there's nothing on the outside fielding that shielding or repulsion. Therefore, this is smaller. The positive charge in the nucleus is pulling these electrons closer together, and so when you have a cation, the atomic size of the atomic radius is smaller than that of the neutral atom because there are no outer electrons feeling repulsion and moving out. So let's think of the same thing with anions. An example of an anion from the periodic table would be something that's a nonmetal, generally located on the right of the periodic table. So in this case, let's oxygen. The atom of oxygen has 8 atoms. So let's draw 8 positive charges in the nucleus. The first energy level, once again, can only have a maximum of 2. The next energy level can have a maximum of 8, but it only needs 6 more in a neutral atom. So again, a neutral atom of oxygen has 6, 7, 8 electrons and 8 protons. An ion of oxygen, specifically an anion because it is negative and gains electrons, has a total or 2 additional electrons. The number of protons is still the same, 8 positive here. There we go. Its first energy level will have 2. The second energy level can have a maximum of 8. And in this case, it's going to need all 8. 1, 2, 3, 4, 5, 6, 7, 8. So when we created our anion, we added electrons, and we added the number of electrons to make the outer energy level full. For oxygen, and for the second energy level, the maximum can have 8. So we added 2 electrons to give us a total of 8 on the outside and 2 on the inside. So an anion of oxygen has 10 electrons. If we think about the atomic radius of an anion, of this anion comparison to the neutral atom, we added 2 more electrons on the outside, and these electrons feel the repulsion from the inner or the core electron allowing it not to feel this positive charge as much. So when you're adding valence electrons or electrons that are on the outer energy level, they're further repulsed by the core electrons, making the atomic size larger. So when we have an anion, its atomic size, atomic radius, is larger than that of a neutral atom. Atomic radius here increases for anion, but when you have a cation moving from the neutral atom to a cation, the atomic radius decreases.